Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 3, Examples of Dilations. Okay, so to get started here, I will need a ruler. Okay, so here what we're doing today. We are dilating. We are going to change the size of objects. And the objects that are going to be of interest are the circle and the ellipse. Okay, so I just put my ruler at 0. So we're going to use the origin as our center of dilation. So I put a dot there at the origin. And what a dilation means is if you measure how far something is from that origin, so I'm just going to pick one point, and I'm going to choose an integer for starters. So I'm going to use millimeters or centimeters. And if you can see right there that I'm lining up my 4 right here, and I'm going to put a dot. And then I'm going to move my ruler, and I'm going to call this dot B, because A is the center. Can't draw a B. There, that's better. All right, so what I'm going to do is put my ruler back there, and see there it's 4 centimeters, or 40 millimeters, and I'm going to draw a line segment from the origin out beyond. Okay, so it says here to dilate circle A from center O, which is the origin, by scale factor of r equals 3. That means we're going to triple the size of this circle. So if my point was at 4, 4 times 3 is 12. That will put me out right here at 12. So I'll put a dot there. It's right there. And I'm going to call that B prime. Okay, obviously I can't draw a circle with just one point. If I know this circle is going to be duplicated up here, it could be this circle here, or it could be this circle here, or it could be bigger, or it could be even bigger. And there's infinitely many circles I can draw with that point on those circles. So obviously I need more points. One is not enough. So I'm going to get rid of those. All right, so I'm going to continue with this. So now I'm going to go over to the other side, and I'm going to find where 4 is on the circle over here, which is right about there. And I'm going to put a dot there, and I'm going to call it C. And then I'm going to put my ruler back here, draw a line all the way out like that. And C is 4. 4 times 3 is, again, 12. So I'm going to be right here. And that is going to be point C. All right, so I'm going to call that C prime. All right, so that's that point there. Again, I can picture a circle here, but if I try to draw it, it would look more like an ellipse until I get out and I'm trying to figure out, now it's starting to look like a melon, okay? So somewhere in there, that's what our circle is going to look like, but again, 2 points is still not enough. So I'm going to go back and I'm going to pick a point on the circle. Let's call it this one here. This one is not an integer though, so here's the point. I'm going to call it D prime. And if I put my ruler there, that is 4.8, which is 48 millimeters. So 4.8 centimeters, or 48 millimeters, times 3. 8 times 3 is 24. 4 times 3 is 12, plus 2 is 14. That's going to come out to be 144. There's 14 here. 1, 2, 3, 4 is right here, approximately there. And I'm going to call that D prime. And this should be called D, not D prime. So there's no prime symbol there. Let me erase that. All right, so let me just clean that up a little bit. Get rid of that. Oop, I don't want to lose the point. Just get rid of that name. And I'm going to call that D. Okay, so now we're starting to see what the circle is going to look like. It's going to come around here, and that's where it's going to be, but we still don't have enough points. So I'm going to use that same line that we're going to draw right here through D, continuing up, not recognizing my ruler now. All right, try that again. Start at 0, and there, that's better. Okay, so there is D, there's D prime. But if you notice, there's also a point down here, and that is going to be E. And when I bring my ruler back here, that is at 31 millimeters. So 31 times 3 is 93. So if I move my ruler back here, 31 times 3 is 91 to 3, which is right here. And I'm going to call that E prime. Okay, so now if I move this out of the way, now I can see where the circle is going to be, but it's still a little difficult to draw. So I'm going to do a couple of more points here, part way between. So now I am at 45, 46, 47 is right here, and I'm going to call that F. And 47 times 3, 47 times 3 is 131, so that's 13.1. So I need to draw a line, not recognizing my ruler for some reason. So I need to draw a line through E, starting at the origin, and I want to go out 131 millimeters. So here's 130, so 131 is right there. And I'm going to call that E prime. I'm going to do the same on the same line that I just drew. Actually, that's F prime. B, E, yeah, that's F prime. This is F prime. All right, so then I'm going to put a point here, and that is at the point 3.2, and that's going to be G prime. So I'm going to call that point G prime, and that's 3.2, which is times 3, 9.6, or 96 millimeters. So I put my ruler back here, 9.6 is right here. And I'm going to call that G prime. Okay. So now I have this point, this point, this point. And as you can see, we're going to come around as getting more and more looking like a circle. I'll do one more line, starting at the origin. This is really struggling with recognizing my ruler. There we go. All right, so this point here, just to speed this up, I'm not going to label it. This looks like about 31 and a half. I'm going to try to be as accurate as possible. 31.5 centimeters, and times 3, 94.5. So about between 94 and 95, right about there, is going to be a point. And when I move my ruler back, I'm going to measure to this point here, and that looks like 47. I haven't done 47 yet, so 47 times 3 is 131. Oh, I did it right here. 131, which is right here. So there's another point. Okay, so now I'm just going to come around and, all right, what's going on here? This point doesn't seem to be out far enough. Let me check that one. Or is D too far? This was 48 or 47. 45, 6, 7, 8. 48 is here. 48 times 3, 8 times 3 is 20, 12, 14, 14.4. No, that's right. Okay, how about this one up here? So F is here, which is 42. Now it's 45, 6, 7, 47, so that should be 131, and it is. So what we need to do here is, let me try getting a compass. And if I put my compass on one point and open it up to the other side, that is my diameter. And that's 152. So half of 152 is 76. So if I close this to 76, that's close enough there. And find the center, which is somewhere here on this line. and then draw a circle, there is my circle. For some reason, I'm off on this point here. It should be more up here. So there is the circle. Same with this point here. That should be more up here. So anyway, here is the circle scaled up 3 units. Okay, I was just looking at this again because I don't like when things don't work properly, and I check my work. 47 times 3 is not 131. 7 times 3 is 21. 4 times 3 is 12, plus 2 is 14. And if I move my ruler over here, it is definitely 14.1, not that point there. And I believe I did the same thing over here, which is right around 14. Okay, so it's this point, not this point. So I multiplied by 3 and got 47 times 3 is 141, not 131. So in doing so, then we do have this circle. Now, if you check, here's my center A prime, and that's the name of my new circle. So there's the center A. So if you look here, the radius is 1 square. Now I tripled it, and look at what the radius is, 3 squares. Okay, we're going to do this one more time. Let me get my ruler. Bring it down to the origin because that's what we're going to center around and dilate from. Trying to get as close to it as possible. There, that's pretty good right there. And what we're going to do is we're going to scale this ellipse up by a factor of 2 from the origin. So if I put my ruler down here, I want to find, first thing I want to find is this point here and this point here. I want to find the top and bottom of this, the highest and lowest point. And if I bring this ruler up here, again, I want to be really accurate. That's between 21 and 22 millimeters. So I'm going to call it 21.5 millimeters times 2. We're doing times 2 this time. 21.5 times 2 is 43. I'm going to come out to 4.3, which is right here. So if I move that and put a dot there, I will call this A, and this A prime. Move my ruler up to the highest point here, and that is right at 45. 45 times 2 is 90, and I'm going to come out to 9. Okay, 45 times 2 is 90. It's right here. Now, I've got a little bit of a problem with that, and I'm going to explain why I'm noticing something here. If this is a vertical line here, A prime and B prime should also be a vertical line, and look at the angle we have going on. So I'm going to remeasure A, see what happened there. So A is, oh, I see. It's 25 plus 1.5, which is 26. 5 times 2 is 10. 6 times 2 is 12. 13. Carry the 1. 2 times 2 is 4 plus 1 is 53. I don't want a dot at 43. I want it over here at 53. So I'm just going to move that point, A, to 53. Let me just erase that one. It's not. Get that out of the way. And then I'm going to move this back up, and I want 53, which is right here. And now that I have A prime where it's supposed to be, this is A prime. That's A prime. It is on a vertical line now. Okay, so these are things you need to look at when you're doing these. Now I'm going to try to find that this is the midpoint of the vertical rise of this, because this is a little more than 3 and a little less than 1. So this is the, if I drew an X through here, the center would be right here. So I want to measure this, which is 38.5 times 2, which is 77. So I'm going to put a dot out at 77. Okay, and then that is going to be C prime. Then I'm going to measure the other side right here, and that's going to be D. If I draw, I haven't been drawing my line, so let me do that. Okay, so now I'm going to draw D prime, where D is right here. Okay, let me erase this line. That was off a little bit. And let me redraw it. Okay, it's important that you're accurate on these. And I draw that there, and D prime is a measure of 3.1 millimeters, so I want to go out to 6.2, which is here on this line here. So 6.2 is right about here. Okay, and that is going to be D prime. So as you can see now, I have an ellipse coming down around like this, okay? And again, I don't have enough points yet, so it's hard to draw it. So if I did this just a couple of more times, let me go through this here, and I'm going to use this point here and this point here. This one's 35, so I want 70, which is right here. And this one is 25, which is 5, 2.5, 25 millimeters or 5. So I want a point here, and I want a point here, and I'm going to go up and do the same over here. Part way across, draw my line, and this point here is 23, and this point here, 23 and 23 is 46, so that's going to go here. 46 is there, and this point here is 41, 2, that would be 84, which is right here. So I want a point here, and I want a point here. Now let's see if I can draw this a little bit better. So I'm coming around, nice smooth arc, down around, and you get the idea there. Okay, so there is, I got to come out a little bit over here. There's the idea of this. So there is my image of my pre-image of an ellipse, which is still an ellipse, which is twice as big. Okay, so I redrew that a little bit better than it was before, and I changed colors to red. So then this is what we're leading up to in this exercise right here. What shape was the dilated image? So it was also an ellipse. So ellipsi, that's plural for ellipse, ellipsi are dilated, then they become, or if an ellipse is dilated, it is still an ellipse. Exercise 3. Triangle ABC, right here, has been dilated from center O by a scale factor of R equals a quarter, which means it is scaled down smaller. So here it is, 1/4 the size of the original, denoted by triangle A prime, B prime, C prime. Using the centimeter ruler, verify that it would take a scale factor of R equals 4 from center O to map triangle A prime, B prime, C prime onto triangle ABC. So this is just asking us to verify that if we scale something down, to scale it back up, we have to do the reciprocal of the scale, R. So our scale factor, R equals 1/4. To get it back to the original, we have to then do a scale factor of 4, which is the reciprocal or inverse of R equals 4, 1/4. So I'm going to measure these. I always like to use centimeters. So I'm going to put the ruler right on my center O, and I'm going to measure, hello, what's wrong with this? There we go. I'm going to measure the distances from O to B prime, and I'm going to write that over here. The length of OB prime equals, and it is 15, 16, 17 millimeters. So if I multiply that, 4 OB primes should equal 4 times 17 millimeters. So in other words, if I scale OB prime up a scale factor of 4, which is what they're asking us to do, they want to know if we will end up back at the original triangle ABC. 7 times 4 is 28, carry the 2, 4 plus 2 is 6. 68 millimeters. So if I look over here, sure enough, here's 70, 68 is right here. So that is 68 millimeters. I'm going to do the same for the next two. So if I move this over now to B, I'm now going to say, oh, that was OC, by the way. Alrighty, that was OC. So let me just fix this. My apologies, but I just caught my mistake. So this is OC equals 17. So 4 times OC prime will get us back to OC. 4 times OC prime was 68 millimeters. Now I'm going to do OB. So OB prime, I'm going to measure. And that is right here. And that comes out to be, it looks like 15 millimeters. And if I measure OB prime and multiply it by 4, then that is going to be 4 times 15 millimeters. And so 4 of the OB primes will equal 60 millimeters. So if I come up here, I'm right at 6 or 60 millimeters. And then I'm going to do the same for OA and OA prime. So OA prime equals 23 millimeters. So 4 of the times the OA prime should equal 4 times 23 millimeters. So 4 OA prime has to equal 92 millimeters, and I am at 9.2. Okay, I measured the distance from center. You could also measure B prime, C prime, and multiply it by 4 and see if we got BC, and measure B prime, A prime, and see if BA is 4 times that, and then measure C prime, A prime, and see if CA is 4 times that. Either way will determine whether or not we can scale it up a factor of 4 and get back to where we started. And the answer is we can. We just verified. Okay, that is the end of lesson 3. Review this lesson summary and go do your problem set.